Okay, guys, so today we're going to be working on chapter 3. Okay, so let's see here. It says statistics versus statistics. There's a capital S statistics and a lowercase s statistics. So what's the difference? Capital statistics with a capital S is the science of doing the stuff that we're going to be doing in this class. It's basically this class, okay? So statistics with a capital S is the science of collecting, organizing, summarizing, and interpreting data. I mean, that's what statistics is. Statistics is answering a question by collecting data. You want to answer a question about a big group by collecting data from a small part of the group, okay? But in order to do a problem like that, there's a lot involved, okay? And so like, how do you collect data, which they talk about in chapter 1, which I'm not really going to go over. You can read that. Organizing data and summarizing data, we're going to kind of talk about that, and then interpreting data, that's kind of like the whole class. But we're going to be focusing on summarizing data today. Okay, so the thing is, I know that population data is a huge amount of data, okay, and sample data, population data we don't collect, but sample data we collect. Sample data is usually a small amount of data. But even though it's a small amount of data, it's usually still pretty big, okay? When I give you quiz questions, I usually give you a small amount of data. Okay, so it's not so hard to do the problems, but in real life stats problems, sample data is usually still a huge amount of data. If, like, for example, if I wanted to know the average age of everybody in America, okay, I would have to talk to 330 million people, okay? So that would be, and then if I did that, I would have population data, the age of every single person in America. But let's say I want to figure that out without talking to all 330 million people, but somehow I'm able to talk to 100,000 people, and I have 100,000 ages. 100,000 ages is super small compared to 330 million, okay? But still, it's big, you know, still the sample data is a lot of data. Real life stats problems, sample data is usually still pretty big, very small in comparison to the population data, but still pretty big. So would you like to look at a piece of paper that has 100,000 ages on it? You wouldn't want to look at that. That just make you dizzy, you know, that's way too many numbers to look at. So what we want to do is we want to summarize the data, okay? We want to kind of say, okay, instead of looking at these 100,000 numbers, can we look at something else that gives me enough information that I'm happy with so I don't have to look at 100,000 individual numbers? So there's two main ways to summarize data. One of them is with a picture or a graph. So instead of looking at 100,000 numbers, would you rather look at 100,000 numbers on a paper or a picture? You'd much rather look at a picture, okay? So if you just look at the picture and it somehow conveys information that you care about the data, then that's all we want. Another way to summarize data is with some numbers. So another way to summarize data is with a small collection of numbers that tells you something about the data. Sounds kind of weird what I'm saying. I'm saying, well, we have 100,000 numbers, and what I'm going to do is I'm going to get more numbers, okay? But again, same thing. Would you rather look at 100,000 numbers or like 5 numbers, okay? And you'd rather look at 5 numbers. And if the 5 numbers conveys information about the 100,000 numbers, then that's much better. Okay, so remember, another thing, let me make sure you understand that whenever I give you data, if I don't tell you what kind of data it is, it's always going to be sample data, okay? Because population data is never collected. It's possible in a problem they'll say, for this problem, here's some data, pretend it's population data. But if they don't say that, then you're always going to assume the data is sample data, okay? And again, sample data is a lot less data than population data, but still it's usually a lot of data. So we want to summarize it, okay? So it's with a picture or with a small collection of numbers. And summarizing the data with a picture, we're not going to go over. You can read that in chapter 3. But we're going to be talking about summarizing a set of numbers with just a couple of numbers here. And that takes us to statistics, a statistic with a lowercase s. So a statistic with a lowercase s is what I talked about last time. Last time we talked about sample statistic. That's what this is. They just left off the word sample today. But when they say statistic, a statistic with a lowercase s, okay, is a number. It's a number that can be calculated from the data, and it summarizes the data in some way, okay? So when I say statistic, I'm always talking about sample statistic, okay? It's calculated from a set of data. What kind of data is this? If I don't tell you, it's sample data, okay? So it's calculated from sample data, and this is called a sample statistic, and it summarizes the data in some way. Okay, so just a quick example here, so we understand what the word statistic means, lowercase s statistic. let's see what it says here. The following data gives the ages of the students in one of my previous stats classes. So here's a bunch of ages of people. Here's some data. Think of this as sample data. Again, it's always sample data unless I tell you it's population data, which I'm almost never going to tell you. Now it says come up with some statistics for this data set. So what I'm asking you is, if I forced you to calculate something from this, but I don't tell you what to calculate, give me an idea of what you can calculate from this data. Somebody give me anything you could calculate from the data, anything.
The average of the students' ages.
You can calculate the average, right? Okay. The average is a number. Okay, this is a number calculated from a set of data. So this is called a statistic. Okay, because any number you can calculate from a set of data is a statistic. Good, so you can calculate the average. Can someone come up with anything else you can calculate? Anything at all that you can calculate from this data?
Mode or range.
Okay, so we're hearing some words, mode and range. Now, if you don't know what these words are, we will talk about them today. But the mode is also a number. The range is also a number. These are numbers that can be calculated from a set of data. Since these numbers are calculated from a set of data, what are these numbers called?
Statistics.
Statistics. Yeah, I'm just testing you on the word statistic. Yeah. Okay. Anything else that you can calculate from data? Anything else?
The percentage of people above a certain age.
Okay. Like percentage of people than, I don't know, 30, let's say. Yeah, that's a number. Again, this is a number that you can calculate from the data. Therefore, this number is called a statistic. Any number you can calculate from a set of data, that's called a statistic. All right, let me ask you some quick questions. When I give you data, what kind of data is it?
Sample data.
Sample data. Unless I specify in the problem, this is population data, which I pretty much will never do. The online homework might do it once, okay? Otherwise, it's sample data. And if you calculate a number from sample data, what's the number called?
A statistic.
A statistic. Good. Okay, any questions so far? Okay, so there's lots of things you can calculate. You guys gave me a few examples. That's good. I have a list of some examples here. So you can calculate the mean, median, mode, and mid-range. If you've heard of these, great. If you haven't, we're going to talk about them today. You can also calculate the lowest number. Like you could calculate the age of the youngest student in the class. You might go, Greg, well, we don't really calculate anything. Okay, I understand. But if you take this data and from the data somehow produce a number, okay, then that number you've produced is a statistic. Okay, so the lowest number, the youngest person in the class, that age, that's a statistic. The biggest number in the data set, that's a statistic. Any number you can produce from a set of data. What else is there? Range, standard deviation, and variance. So these are just a bunch of words that I'm assuming a lot of you haven't heard of yet, but we're going to talk about it today. So the range, the standard deviation, the variance, these are all numbers that can be calculated from this data. So they're statistics. Okay, cool. And so anyway, so that's what chapter 3 is about, summarizing data numerically. Okay, and we're going to cover section 3.1 and section 3.2. All right, so let's do 3.1 first. Measures of central tendency. So the book calls the section measures of central tendency. I call it measures of center. Okay, why would you want to know the center of data? Story. I'm going to give you a story. So this story I'm going to give you is a fake story. Okay, so just take it easy when I tell you the story. Don't be like, oh my God, what? Okay, but let me just tell you the story. So this is the story I usually tell the students. Usually I don't tell them it's a fake story in advance, but I'm just telling you it's a fake story. But anyway, I want you to pretend that this is the last day that I'm teaching at Rio Hondo College. And the reason it's the last day is because I'm going to work at another school, and there's 2 other schools that both want me to work for them. And I'm trying to decide which one to work for, okay? So we have 2 schools, okay? That's the best drawing of a school you're getting. You're getting a house, okay? So school A, let's say, and school B, there's 2 schools. And both schools are equally close to my house, okay? So they're very close. Wow, I can't spell school. Wow, that's pretty bad. Okay, let's try this again. School A and school B. Okay, so I'm trying to decide where to work. They're both equally close to my house. They're both paying me the same. They're both nice campuses, and they both have 100,000 students. So I'm trying to decide, okay, well, how do I decide from that information? You know, there's nothing to decide from. So then I go, okay, I want to know something about the ages of the students. Well, so I could say the following. I could say, okay, school A, I want you to send me a list of the ages of all your students, and they're going to send me a list of 100,000 ages. And then I could say the same thing to school B, send me the list of ages of all the students at your school, and they're going to send me another 100,000 ages. And I don't want to look at 100,000 numbers on a piece of paper. So instead I can say, okay, give me the center age at your school, and the same thing for this school here. What's the center age? Give me an idea of a middle age. So some people are older, some people are younger, some kind of center. And let's say school A, okay, says the center age at our school is 24, okay? And this other school says the center age at our school is 39, okay? Now I have some information. You see, with just knowing the center of that 100,000 numbers and the center for that other 100,000 numbers, I don't need to look at all 100,000 numbers. I just know the center, and that might help me make a decision. I might say, okay, well, it looks like in general they're younger at this school, and if I'm able to communicate well and teach younger students, then maybe I'll go to this school. And it looks like the students in this school are generally older, and so if I'm able to communicate better with older students, maybe I'll choose this school, kind of thing. Okay, but that's all I'm trying to say. The whole point of the story is to give you an idea of why you might care about the center. It's a fake story, but again, just instead of knowing all the numbers in the data, just knowing just the center alone gives me, I'm able to make a decision just from those things. Okay, so there's an example of why we would want to know the center. Now, there's 4 ways of measuring the center. There's actually way more than 4 ways of measuring the center, but there's 4 ways of measuring the center that we're going to talk about. Okay, so the first one is called the mean or the average. The thing is, everybody in here knows how to find the average, okay? But I'm teaching you extra things today. One thing I'm teaching you that you may or may not have known is the average. What's the point of it? It's supposed to give me an idea of the center of the numbers. I want you to imagine there was a guy, his name was Average, okay? And he came up with a way of measuring the center, and he said, you know, add all the numbers and divide by how many you have. Now, the symbol for the average, we have 2 symbols for average. One of them is x, one of them is mu, one of them is x bar. Which symbol am I going to write over here for the symbol for the average? Mu or x bar? Which one?
X bar?
How come x bar? It's because the data is sample data. If it's sample data, the average of the numbers in sample data is called x bar. If it was population data, which it pretty much never is, then it would be mu that I'm finding. Okay, but it's x bar that we're finding. Okay, so notation is x bar. Why? Because it's sample data. And then the way you find the average, you guys know how to do it. You add the numbers and you divide by how many you have. That's what it says here. Add all the data points together and divide by how many you have. Okay, we'll do an example in a minute. Okay, this person came up with a way of measuring the center of the data. Someone else said, well, wait a minute, I have another way. I don't like your way. And so he came up with another way, and you could pretend the guy's name was Median, okay? His name was Median, and he said, okay, I got another way of measuring the center. His notation, the notation for the median is x tilde. It's kind of like an x bar, but instead of it being a line, it's kind of like a squiggly line. They call that x tilde. The notation is important when you're doing problems on the quiz next time. I'll be expecting the notation. So this is another way of measuring the center. And the way you measure the center using the median, the way you find the median is the following. The median is the number in the middle of the data if the data is put in order, okay? That's what it says over here. So how do you calculate it? Well, first thing you have to do is you have to put the data in increasing order, because that's very important. Put the data in increasing order. Now, then the median will be the number right in the middle if there's a number right in the middle. For example, let's say you have 5 numbers, 1, 2, 3, 9, 12. Well, 3 is the number right in the middle, okay? And this set of data has a number in the middle because there's 5 numbers. If you have an odd amount of numbers, there's always going to be a number in the middle. Like if the data is 1, 7, 11, there's 3 numbers there, there's a number right in the middle. But sometimes your data has an even amount of numbers like 1, 4, 9, 13, okay? When you have an even amount of numbers in your data, there isn't 1 number in the middle. There's 2 numbers in the middle, okay? So when you have 2 numbers in the middle, how do you find the median? The answer is you take the 2 middle numbers and you take the average of them, okay? So anyway, how do you calculate the median? First thing you do, put the data in increasing order, then N, by the way, lowercase n is going to stand for how many numbers there are in your data set. Okay, so if you have an odd amount of numbers, the median is just the number in the middle and that's it. Okay, but if n is even, if you have an even amount of numbers, there isn't going to be a middle number. There's going to be two middle numbers. The median is the average of the two middle numbers. We'll do an example in a minute. Okay, so then another person said, I don't like either of those ways of measuring the center, and he came up with his own way of measuring the center. See, there's no word center, like there's no mathematical definition of the word center. So people said, well, how are we going to figure out the center? And they came up with different ways. Different people came up with different ways. Average is one person's way. Median is another person's way. Another person came up with another way, and they call it the mode. The mode is another way of measuring the center. You could think of it as the guy's name was Mode. Okay, and he said, okay, how do you figure out the center? There's no universal notation for this, so I'm not going to write a notation for this. But how do you calculate the mode? The mode is the number that appears the most if there's numbers that repeat in your data set. Okay, so like for example, let's say my data set is 1, 2, 2, 4, 4, 4, 9, 9, 11. Okay, let's say that's my data set. Well, 2 repeats, 4 repeats, and 9 repeats. This, I shouldn't write 11. You're going to think that's 1, 1. Okay, let's do 15. Okay. So the 2s, the 4s, and the 9s are there more than once. But which one repeats the most? The 4 does. Because it's there 3 times, but these other numbers, the 2s and the 9s, are there 2 times. So the mode is going to be 4 in that case. Whichever number repeats the most. If the data set looks like this, let's just put a 10 there. Okay. Now these numbers repeat, and these numbers repeat. Which one's the mode? Well, this time these repeat the most, and also these repeat the most. So which one is the mode? The answer is, for mode, there could be more than one answer. So in this problem, the mode would be 4 and also 9. You'd write them both down. Let's make sure that's clear. For median, you can't have more than one answer for median. Okay, there has to be only one answer. So if there's 2 numbers in the middle, you have to take the average of them. But for the mode, there can be more than one answer. You can have multiple answers. It's possible. So you don't find the average of the ones that repeat the most. You just write them both down. Okay, let's see what it says here. So I'm going to calculate it. It's the number that appears the most often. There could be more than one mode. And if none of the numbers repeat at all, then there's no mode. Okay, we'll do examples of calculating it in a minute. Let me get to the fourth one. Fourth way of measuring the center is the mid-range. Now, this one is kind of ridiculous in the sense that students always get this one wrong. And it makes me very sad because it's very easy. But you probably haven't heard of this one before. You know, I'm sure if you've ever seen stats before, everyone's seen a little bit of stats. Mean, median, mode, you've all heard those. Okay, maybe you don't remember what they were or whatever, but you've heard of them. Mid-range, hardly anyone's heard of that one. Okay, so it's real easy. Just, you got to study. Okay, just go over it for a few minutes. Don't forget it. Mid-range. How do you find the mid-range? Well, first of all, there's no universal notation, so I'm not going to write the notation. But the way you calculate the mid-range, it's super simple. All you do is you take the lowest number and the highest number in your data and find the average. That's it. You find the average of the highest and lowest numbers. That's what it says here. It's the average of the highest and lowest numbers. That means you take the lowest number in your data set and the highest number in your data set, you add them and you divide by 2. Okay, so we're going to do a couple of examples. First example, find the mean, median, mode, and mid-range of the following data set. Here's the data set. We want to find the mean, median, mode, and mid-range. Okay, so the first thing I'm going to do, let me just go one more slide over. Yeah, okay, here it is. Same problem. Okay, I just made it a little smaller. Very first thing you need to do is put the data in increasing order. Now, you really only need it in increasing order for the median, but if you put the data in increasing order, it's going to help with the mode and it's going to help with the mid-range. So you might as well do that at the beginning. So I'm going to put the data in increasing order. So we'll start with the smallest number, which looks like it's 2. And then let's see, there's a 4 twice. What else? I see 3 10s, it looks like. One, 2, 3 12s. What else? looks like 15 and 19. If I got it right, I'll double check it here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then up there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, cool. So very first thing you do is put the data in increasing order. Okay. So again, if I ask you this question on a quiz, everything that I write down now, I'm going to want you to write it like that. So first put the data in increasing order. Then I'll just call this part A. We're going to find the mean. Because it says find the mean, median, mode, and mid-range. The symbol for mean is X bar. Notice I never asked you, I didn't say don't forget the symbol, but don't forget the symbol, okay? I want you to write the symbol every time. Please don't forget. So notation for the mean is X bar. Okay, now how do you find it? What do you do? Someone tell me what you do to find it.
Add all the numbers and divide by how many numbers are.
Right, add all the numbers up, divide by how many you have. So you're gonna do, now watch what I'm writing here, okay? So you're gonna do 2 plus 4 plus, what I like to do is, I mean, I could write down every number. I don't want to do that. When it's a bunch of numbers, I usually write down the first two, and then I put like a dot, 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 like you guys get the idea, and then I write down the last one, 19. You divide by 11 because we have 11. Now, if you don't write this step here, I won't take off points. But let me just warn you about something. It's very important that you show your work, especially if your answer is wrong, because if your answer ends up wrong, then I'm not going to know if it's wrong because you didn't know how to do it, or is it wrong because you knew how to do it, but you typed it in the calculator wrong or something like that. So if you write this, then I'm going to go, oh, they know how to do it. So if your answer ends up being wrong, then I'll go, oh, they just punched it in the calculator wrong. And then you'll be able to get partial credit at least. Okay, so that's the idea. So I advise you to write this, but you're not required to write it as long as you got it right. But you are required to write this and get the answer. So let me go ahead and do this real quick. Now, when you're adding them, you got to be careful how you type it in. So make sure everyone understands what I'm saying. You need to add the numbers, get the answer, and then divide by 11. Okay? So let me go ahead and do that first. So let's see. If you add the numbers, 2 plus 4 plus 4 plus 10. So what I'm saying to you, let me say it one more time. Add all the numbers, get the answer, then divide by 11. To emphasize that even more, I'm going to write down what we got when we added the numbers, and then we'll divide by 11, and the answer is 10. I'm going to write this answer in blue here. Because one of the things we're going to have to work on in here is how to type things in the calculator correctly. That's its own issue, okay? So if you type things in wrong in the calculator, it's going to give you a totally wrong answer. So I guess what I'm trying to say is if you do 2 plus, here, let me do it again on my calculator. 2 plus 4 plus 4 plus 10 plus 10 plus 10 plus 12 plus 12 plus 12 plus 15 plus 19. And if you just push divide by 11 without getting the answer to the top first, then what it's going to do, it's only going to divide the 19 by 11, and you're going to get like a 92.72 whatever answer. So if you're doing this right now, or later on when you're studying for doing this, if you get this answer, then you typed it in wrong. Why'd you type it in wrong? Because you need to add the numbers, get the answer to it first, and then divide by 11. Then you'll have the right answer. Okay. Any questions on the mean? Okay, sounds good. Let's go to the next one. Median. The symbol for the median is X tilde. Make sure you put the symbol if it has a symbol. Those are the only two that have a symbol. The median is the number in the middle if there's a number in the middle. Is there a number in the middle here?
Yes.
Yeah. Because there's 11 numbers, when there's an odd amount of numbers, there's going to be one in the middle. Which one's in the middle?
10.
Which 10? There's 3 10s I have written down. Which one is the one in the middle?
The last one.
We're the last one. The last one.
That's right. Yeah, because you can see there's 5 numbers after it, 5 numbers before it. So yeah, that's the number in the middle. Yeah. Don't look here, okay? You have to put an increasing order first, and then it's the number in the middle. Okay, so 10. So median is 10. Now, just so you guys know, it's a super big coincidence that we got the exact same answer for the mean and the median. Most of the time, they're not going to be the same. We expect them to be somewhat close because they're both supposed to be giving me an idea of the center. But don't expect them to ever be the same like they are here. But it could happen that they're the same. Okay, questions on the median. Okay, next one, mode. There's no notation for the mode, so I'm just going to write down the answer now. It's the one that repeats the most. So 4 repeats, 10 repeats, and 12 repeats. The rest of them don't repeat. They don't appear more than once. But the mode is the one that repeats the most. Which one repeats the most?
10 and 12.
10 and 12 both repeat the most. So you have to list them both. So this set of data has 2 modes, 10 and 12. Don't find the average of them or anything. You just list them both. Okay, questions on the mode. Okay, fourth one, mid-range. Oops, not E, what am I doing? The mid-range. So to find the mid-range, you take the lowest number, and then you take the highest number, you add them, and you divide by 2. When you put them in order, then the lowest one is right here, so that's 2. Then the highest one is over here, that's 19. Just add the lowest and the highest, and you divide by 2. And again, when you do this, you have to add the top first, get the answer, so it's 21, and then divide by 2. And it looks like the answer is 10.5 for that. Any questions on this example? Okay, so when you're doing a problem like this, you have to know how to calculate the things. That's the first thing. You have to put the symbols. That's the second thing. And the third thing, which is probably more important than all of that, is you got to know what the point of it was. Like, what's the point of every number that's in blue? 2 things. First of all, actually, let me say 3 things. First of all, this data here, what kind of data is this?
Sample data.
Sample data, that's right. If I give you data and I don't tell you that it's population data, then you always assume it's sample data. Okay, the 4 numbers in blue, these, well, I guess there's 5 numbers, whatever. These numbers that are in blue were all calculated from the sample data. Therefore, these numbers are called what?
Statistics.
Statistics, that's right, okay. And the last thing is, these 4 statistics specifically, mean, median, mode, and mid-range, are supposed to tell me what about the data? What am I supposed to be figuring out about the data from these numbers?
The center.
The center. So that's what's very important, okay? The goal of these 4 blue numbers is to give me an idea of the center of the data. And again, in a real life stats problem, it wouldn't be 11 numbers. It'd be like, 50,000 numbers. And you'd much rather just look at this and it gives you an idea of what the center is. If you just look at those, you go, oh, the center is 10, 11, 12-ish. It gives you some kind of idea of what the center is. Okay, we're gonna do one more like this. Any questions on this one though? Okay, one more. So same question, just a different set of data. Find the mean, median, mode, and mid-range of this data. First thing we're gonna do is we'll put the data in increasing order again. Data in increasing order. Okay, the smallest one is 2, and then there's 4, and then there's 8. Let's see, 11, and then 17, 19, 23, and 31. I think I did it right. Let me double check. So I'm gonna double check by counting and see if I got them all. So there's 8 numbers here. There's 8 numbers there. I think I got it right. Okay, so put the data in increasing order first. All right, then mean. Again, the symbol for it, which you're not going to forget. On the quiz, I'm not going to remind you to put it, so just don't forget to put it. So symbol is X bar. And again, you know how to do it. You add them, 2 plus 4 plus ... all the way up to the last one, 31. You divide by how many you have, which is 8. And again, when you type this in the calculator, you first add them all, get the answer, and then afterwards you'll divide by 8. It's 2 plus 4 plus 8 plus 11 plus 17. Plus 19 plus 33 plus 2. I'm getting 115. Let me double check that before I move on though. 31, 54, 73, 90, 109, 110, 115. Yeah, okay. So it's very important when you're calculating the average. Add them, get the answer. Don't type it all at once with the divide by 8. Get the answer and then divide by 8. And the answer to this is 14.375. Sometimes I'll see students look at this 14.375 and they'll write 14.37. You know, I don't know what's going on there. Like 3 decimal places is too much to write, so they just don't put the 5 or something. I don't know. But, you know, write the whole thing down. You know, write it down. Sometimes students are wondering about rounding, and my quick answer for now is if you're not sure, write the whole thing down. You know, it won't hurt. It'll only take a couple more seconds to write the whole thing down. Okay, there's the mean. Any questions on the mean? Okay, next one, median. Again, the symbol for median is X tilde. It's the number in the middle if there's a number in the middle. But this time there isn't a number in the middle because there's an even amount of numbers. We have 8 numbers. There isn't one number in the middle. There's 2 numbers in the middle. Can you tell me the 2 numbers in the middle?
11 and 17.
11 and 17 are the 2 numbers in the middle. I know that's right because there's 3 after and there's 3 before. So yeah, so those are the 2 numbers in the middle. Now, for median though, you can only have one answer. So you don't write down 11 and 17 as like 2 answers for the median, okay? You don't do that, okay? What you do is after you find the 2 middle numbers, you have to find the average of the 2 middle numbers. So you just do 11 plus 17, and you divide by 2. So it's the average of the 2 middle numbers. So add the 2 middle numbers, you get 28, and then divide by 2. And the answer to that is 14. Again, pretty big coincidence how close these are. Don't expect them to be that close, but sometimes they're close. Okay, questions on the median. So yeah, remember median can only have one answer. So if there's 2 numbers in the middle, take their average. Okay, the mode is the next one. And to find the mode, it's the number that repeats the most. But in this data, nothing is repeating at all. All the numbers are different. So in that case, the answer for the mode, you're going to write no mode. No mode. A number has to appear more than once for there to be a mode. Okay, and then last one, mid-range. Again, to find the mid-range, you take the lowest number and the highest number, and you add them, and then you divide by 2. So you take the average of the lowest and the highest one. The lowest is 2. The highest is 31. Add them and divide by 2. When you add them, you get 33. So add them first, and then divide by 2. And what is it, 16.5? Is that right? 16.5. Okay, and that's how you do that one. Okay, one more time. This data, what kind of data?
Sample data.
I'm sorry, louder?
Sample data.
Sample data, that's right. Okay. These numbers, all the numbers that I have boxed in blue, well, I know there's no number here, but the rest of them, those numbers were all calculated from the sample data. Therefore, they are called what?
Statistics.
Statistics, right? More specifically, sample statistics. But you know, if it came from population data, those would be called population parameters. But it's sample data, so those are statistics. Okay, and again, the mean, median, mode, and mid-range are supposed to tell me what specifically about the data.
The center.
The center, yeah. This is 4 different people's ways of figuring out the center. And if you look at this answer, you go, oh, the center is somewhere, you know, 14, 15, 16, 17-ish. You know, it gives you an idea of the center. We don't have one way of measuring the center. We have a bunch of different ways. So it just gives us an idea of what the center is. Okay, any questions? Go ahead.
For mode, I thought it'd be 0. Would that affect any of the other statistics, or it has to be no mode?
No, it has to be no mode. It's not 0.
Okay.
For the mode to be 0, that means the number 0 would have to appear, and it has to repeat more than the other ones.
Oh, okay.
So it's not like the mode is 0. It's that it doesn't have one. Okay, other questions?
There's
Okay,
no,
oh, go ahead.
sorry, there's no symbols for mode and mid-range like there is for mean and median.
There's no universal symbol. Different books have their own symbols, so I'm just not giving you a symbol.
Okay, thank you.
Like in the pre-stats class, I think they use a capital M for mode, but it's not universal, so I'm just not going to use it. Okay, so just 2 more things. Let me just remind you, don't forget the symbols for these on the quiz next time. And also, don't forget how to calculate mid-range. It's so easy that it's sad if you lose those points because it's free points. You know, it's just add the lowest and highest, divide by 2. People sometimes will subtract them instead of add them. Sometimes people will forget to divide by 2. People do all sorts of weird things. So it's because you haven't seen it before. I'm guessing most of you haven't seen it before. So just make sure you go over it for a few seconds because it's easy. You just have to remind yourself how to do it before the quiz. Okay, so that's all I'm going to say as far as section 3.1 goes. So now we're going to go to section 3.2. So measures of dispersion is what it's called, measures of spread. Knowing the center of data is great, okay? So instead of looking at the data, I just know the center. It gives me some information. I already showed you it gives me useful information as far as helping me make a decision, okay? So it's nice to know the center, but knowing the center alone isn't enough. A lot of times we're going to want to know more than just the center. Let me give you a quick example here. Here's a data set, 0, 20, 40. There's a set of data with 3 numbers in it. Here's another data set, 19, 20, and 21. If you calculate the mean, median, mode, and well, none of these have a mode, but if for the top one, the mean, median, and mid-range, they're all 20. So mean, median, and the mid-range for the data. If you calculate it, they're all the same. They're all 20. For the bottom set of data, same thing. The mean, median, and mid-range is 20 again. So the center, no one is going to disagree. The center is definitely 20 for both sets of data. But if you look at the data, they're definitely different, okay? What's different about them? The bottom numbers are really close together. The top numbers are much more spread out. So we don't want to just know the center. We're going to also want to have an idea of how spread out the data is. And that's what section 3.2 is about. So we want to calculate something from this data up here that gives me an idea of how spread out it is. And then we should be getting a big number for this because of this, the numbers are spread out. And then whatever we calculate for the bottom one, we want it to be a small number because the numbers are closer together. Okay, so besides wanting to know the center, we also want to know how spread out the data is. Okay, so now I'm going to go back to that fake story and give you another way to understand, a little story to understand why I would care about why things are spread, how spread out the data is. So it says here, why would you want to measure the spread of the data? So the story. So I'm going to give you the same story. So again, I want you to pretend that I'm not going to teach at Rio Hondo anymore. And I'm trying to decide on which 2 schools to go to. They both said they want me to teach there. So I have school A. I have school B. They're both equally close to my house. They both pay the same. They are both nice campuses to work at. They both have 100,000 students. And I say, okay, give me an idea of the center age at your school. And let's say both of them say the center age at our school is 30, both of them. Well, I can't make a decision off that because they gave the same answer, right? They both said 30. So I'm like, okay. Well, why don't you give me a little bit more information? Give me an idea of how spread out the ages are at your school. Meaning, are the ages at your school close together? Are all the ages really close together? Or are they really spread apart? Okay. And let's say the first school says, okay, the spread of the ages at our school is 2, whatever that means. I don't know what that means, but the spread is 2. And the other school says the spread of the ages at our school is 15. Now I can use this to make a decision. Small number for the spread means the numbers are real close together. So the ages at this school are very close together. Bigger number for the spread means the ages at this school are all over the place. They're much further apart. I don't know exactly what the 2 means or what the 15 means, just because 15 is bigger than 2, the ages here are more spread out than the ages over here. And from that information, I can make a decision on which school I want to teach at. Like, for example, what school, from this information, what school do you think I would want to teach at? Any ideas?
Do you
School A.
book older students or younger students?
So, okay, so I did hear someone say school A. I'm guessing the person who said younger students is still saying school A. Okay. Okay, so most of the time students tell me school A, and that makes sense because what is it saying? Listen, there's different generations of people, and I'm a certain generation. Can I communicate to different generations of people? If the ages are all over the place, like at school B, okay, where the spread is big, so that means they have very young students, they have very old students, the ages are all over the place, okay? If that's the case, I have to be good at teaching young people, the people in their 20s, people in their 30s, people in their 40s, people in their 50s. I have to be able to communicate well with all of them. They have to all be able to kind of relate to me, understand what I'm saying. So that would be harder, okay? Because different generations, you know, learn differently kind of thing. So that would be a harder school to work at. If I wanted to work at this school, well, as long as I can communicate to people that are pretty close in age to 30, all the ages are very close to 30. You know, like you might get somebody in their 60s or 70s, but maybe one student, you know. Most people will be, you know, in their 20s, maybe some in their 40s, but very close to 30 is what this is saying. The ages are all close together. So as long as I can communicate to one of them, I can communicate to pretty much all of them. Okay, so school A is the easier one to work at as long as you're able to communicate to people around 30, as long as they're very close to 30. The part B would be, you know, harder because the ages are all over the place. So yeah, if I want the easier situation, then A is probably the way to go. Of course, so most people would select A, totally get it. And I probably would select A too, but the truth is I'm the kind of person that wants the challenge. So I'd probably select B and be like, bring it on, let's figure out how to do it. But just understand that just knowing the spread of the ages helps me make a decision. Okay, so that's the goal of this story, is that knowing the spread of data is useful. It helps me make some kind of decision. Okay, so there's 3 ways of measuring the spread. There's more than 3, but we're gonna go over 3 ways of measuring the spread. The first one is called the range. Someone had mentioned range earlier. Look, the way you find the range is you subtract the highest and lowest numbers. You do the highest number minus the lowest number. If you want to know how far apart things are, you subtract. So it really makes sense that we're going to be subtracting. For example, let's say somebody is 23 years old and someone else is 27 years old. How far apart are they in age? They're 4 years apart. It lets me know how close the numbers are. So subtracting the numbers gives me an idea of how far apart they are. Okay, they're 4 apart. Okay, so that's the idea. So the range, the way you find the range, you just subtract the highest and lowest numbers. So that's pretty easy. So the range is pretty easy to calculate. A couple things to tell you. First of all, you have to do it in the right order. You got to do highest minus lowest. If you subtract in the other order, you're going to get a negative number, and your range is not allowed to be negative. So make sure you do the highest one first minus the lowest one. So you do 27 minus 23, and you would get 4. Okay, if you do it the other way, you get -4, so don't do that. Range is the easiest one to calculate, and it makes the most sense that you subtract the numbers to see how far apart they are. But which numbers in the data set do you subtract? The highest and the lowest ones. But there's some bad stuff about the range. There's some things we don't like about the range. Okay, what don't we like about the range? The thing I don't like about the range is that it only uses 2 numbers in your data set, the highest and the lowest, and it ignores all the rest of the numbers. For example, let's say you have 100,000 numbers. Well, you're going to subtract the highest and lowest to get the range, and you ignored 99,998 numbers. Okay, so that's one thing we don't like about the range. We have the same issue with mid-range. I'm going to go back. Well, I'm going way back, I guess. So mid-range, it only uses the lowest and highest. So again, if we have 100,000 numbers, it ignores all the rest of the numbers. It just uses the lowest and highest. So mid-range and range are pretty easy to calculate, but they're not our favorite ways of measuring center and measuring spread, okay? Because it ignores most of the data. We want a way to measure the spread that uses all the data. Kind of like average. Average measures the center, and it uses all the data. You add all the numbers up, and you divide by how many you have. So we want to come up with a way of measuring how spread out the data is and use all the numbers in the data. Okay. And this is going to bring us to a story now. So I'm going to have to tell you a story. It's going to be kind of a long story. The story I'm going to be giving you is whoever came up with this way of measuring the spread, not range, the next way that I'm going to teach you right now. I'm going to tell you a story of what they might have had to go through to come up with the way of measuring spread, because it's more involved. I'll tell you that in a minute, but let me just go over the 2 ways real quick. So the other way of measuring spread is called the standard deviation. We have 2 symbols for standard deviation, sigma and S. Which one are we going to be using? S, because it's sample data we're finding the standard deviation of. So S, okay? So symbol is S, and the way you calculate it, okay, here's how you calculate it. Ready? Here we go. You take the square root of the almost average of the squares of the distance each data point is from the mean of the entire data set. I wrote that sentence down, and it's kind of funny, like, what the heck? You know, there's like a lot of stuff in that little sentence there. But that's why I got to tell you a story. So I'm gonna tell you a long story, and we're gonna get through all what the heck's going on here. Okay, but anyway, so that's the main one. Okay, measuring how spread out the data is. That's what standard deviation does. It gives me an idea of how spread out the data is. And so just know the notation for now, and we'll talk about how to calculate in a minute. Once you understand this one, then the other way to calculate how spread out the data is the variance. And the symbol is s squared. You just square the standard deviation. So the way you calculate it, square the standard deviation. So the standard deviation is the one that's weird and hard to calculate. But once you calculate it, then the variance is really easy to find. Okay, so here we go, story. It says derive the formula for the standard deviation of a data set by finding the standard deviation of this data set. So we're going to calculate the standard deviation of this data set, but as I go, I'm going to tell you a story. So just bear with me here. Is it smaller here? Okay, cool. So we want to find the standard deviation of this data set. Okay, so remember what we're trying to do. I'm trying to measure how spread out the data is. So how spread out is it? And I want to use all the numbers. Okay. Real quick, can you tell me what the range of this is, just to practice range? What's the range?
11.
11. You do the highest minus the lowest, it's 11. And again, range, subtract to see how far apart the numbers are. Subtracting makes the most sense for how to figure out how far apart numbers are. But the problem is it only uses those two numbers. So I like the idea of subtraction, okay? So keep that in mind. I love the idea of subtracting to figure out how far apart things are, okay? But I don't want to just subtract the highest and lowest. So what we're gonna do is instead of finding one range, we're gonna kind of find a lot of ranges. I kind of want to do a bunch of subtractions. Figure out how far apart all the numbers are from kind of like each other. So you might go, okay, what should we subtract? So we could do 12 minus 1, 12 minus 2, 12 minus 4, 12 minus 11. We're not going to do that, just bear with me. We could do that, and that would give me like 4 ranges, so to speak. Okay, 4 subtractions, 4 ranges, 4 distances, okay? And then you might say, well, what's so special about 12? Why are you using 12 with all the other ones? Why don't we choose 1? Why don't we do 12 minus 1, 2 minus, so, okay, we'll do 2 minus 1, 4 minus 1, 11 minus 1, 12 minus 1. And then someone might say, well, what's so special about 1? And then you're like, okay, well, we're going to have to subtract from something. So the person who came up with this, they said, okay, why don't we find the center of the data first, and then figure out how far each number is from the center. So first thing you do, you're going to find x bar, which is the average of all the numbers. 1 plus 2 plus 4 plus 11 plus 12, divide by 5, so we have 5 numbers. The answer for the average is 6. So why are we doing this? This is the number we're going to use when we do our subtractions. So instead of figuring out how far apart the 12 and the 1 are and so on, we're going to figure out how far apart is each number from the center, and we're going to use the average for the center. Okay, so the idea is instead of finding one range, we're going to find a bunch of ranges. So we're going to do a bunch of subtractions. We're going to subtract each number in the data set minus the mean. We're going to use the mean as the number we're comparing it to. So then what you do is you make a 3-column table. In the first column, I'm going to put an X. X stands for your data. So I'm just going to list the data here. 1, 2, 4, 11, 12. And then in the second column, I'm going to subtract. I'm going to take each number in your data set. I'm going to minus the mean, 6. So we're going to do 1 minus 6. I'll do it in a minute. Then we're going to do 2 minus 6. We're going to do each number in the data set minus 6. We're going to do 4 minus 6 here. What's the next one going to be?
11 minus 6.
11 minus 6. Next one? Anyone?
12 minus 6.
12 minus 6, right. These are called deviations. Think of it as a bunch of ranges, okay? And I'll go ahead and subtract these. And we subtract, okay, you're getting a negative here, -5, -4, -2.
So the numbers that you just got from subtracting 6 those are all deviations from the average?
Yes, that's right. Those are all deviations from the average. How far is each number from the average? Right. So think of this as 5 ranges. Instead of having one range, we kind of have 5 ranges. But yeah, some of them are negative. And now the guy said, whoever, so remember, there's some guy who came up with this, right? And he said, okay, now what we'll do is we'll take the average of these, okay? He said, okay, let's find 5 ranges and we'll take the average, and that'll be like an average range. It'll be like an average spread, okay? So what you have to do is you have to add the -5, the -4, the -2, the 5, and the 6. You have to add these and divide by 5. If you add them all and divide by 5, you're going to get 0. Okay, do it on your own. Just double check that I'm right, but you're going to get 0. And it turns out that you're going to get 0 every single time, no matter what the data is. So the way this guy came up with for measuring the spread sucks. It doesn't work. Every data set has spread 0. That doesn't work. Okay, but the ideas were good. You know, he's like, okay, let's find a bunch of ranges and find the average range. Okay, so things were good, but we get 0 every time. Now, why are we getting 0 every time? The reason is because they're negatives and they're positives, and the negatives and positives are canceling each other out. We don't want the negatives and positives to cancel each other out. So basically, I don't want any negatives in my answer. So now we have to come up with a way of getting rid of the negatives. So you have to imagine the guy probably went to bed that night when he figured out that all the standard deviations were 0, and he was real depressed, like, oh, I failed. Then the next morning he woke up and said, you know what, I'm going to give it another try. He said, let's get rid of these negatives. So how are we going to get rid of the negatives? One way to get rid of negatives is to use an absolute value. Absolute value is just erase negatives. And that's the way that makes the most sense to me. But we're not going to be using absolute values. Absolute value, again, would just make this a 5 instead of a -5 and a 4 and a 2 and a 5. You know, it would just erase negative signs. That's what absolute values do. But that's not what we're going to do. And the main reason is because when it comes to formulas and stats, absolute values suck. Absolute values are not easy to work with. And so this person came up with another way of getting rid of negatives. And his way of getting rid of negatives would be to square the numbers. Now, you may have heard that when you square a number, it's positive. Okay, so that's the idea. So he said, okay, we're going to square all the numbers, and that'll make it positive. So in the next column, I'm going to write down what I had written in the previous column, and then I'm going to put a square around it. So we're going to square the number. We're going to raise each number to the power 2. Now, the first one here, it's -5 to the power 2. Okay, let me stop real quick here. Another calculator issue, okay? If you don't, when you're squaring a negative, if you don't type it in right, it's going to be wrong. So make sure you guys understand this. If you type it in like this, okay, you know what? I should pull out the calculator. At this point, I think pulling out the calculator. Okay, so a couple things to tell you. Again, learning things on the calculator is going to be a theme in this class. We're going to have to work on that a lot. Okay, so first of all, if you're going to type -5, don't push this symbol. Okay, this is subtraction. You're going to, if you type -5 like that, anyway, it's going to give you an error if you don't use that. This is the negative sign down here. Okay, -5. But check this out. -5, and then here's the square button if you want to square it. Before I get the answer, what do you think the answer is?
25.
25, right. That's what it should be, 25. Because squaring will get rid of the negative, and 5 times 5 is 25. But look what the answer is. The answer is -25. Why? I typed it in wrong. I want to make sure you guys understand the difference between that and this. If you put parentheses, -5, close the parentheses, and then square it. This is the right way to type it in. So check this out. This is something I would teach like in a pre-algebra class or whatever. But here's the deal. When you square a number, it only applies to the powers only apply to what's right next to it. So this power 2 is only going to square the 5. It will not square the negative. So the negative gets copied down. But when you put parentheses like this, the power is right next to the parentheses. That means the power applies to everything in the parentheses. So not only is the 5 going to get squared, but the negative will also get squared. And when you calculate this, why isn't it calculating? And you get positive 25. So remember, the whole point of squaring is to get rid of the negatives, but you must put parentheses. Just keep that in mind. When you're going to square a negative, you must put the number in the parentheses, and you got to put the power 2 outside the parentheses. And also, don't forget to use this symbol down here for the negative sign. Don't use the subtraction symbol for the negative sign. So that's why I wrote it with the parentheses over here. All right. So you just got to be careful. You know, you mess that up, and it's going to mess up the whole answer and everything. So, okay, here we go. So back to business. The next one is going to be -4 squared. Oops. Next one's going to be -2 squared. Again, notice the parentheses with the negative number inside it. The power 2 is outside. Now, for the last two, they're positive. You don't have to put the parentheses, but you can put it if you want. I'll go ahead and put it. But when it's a negative, you must put it, because otherwise it's not right. Okay, so you square these numbers and you get 25, 16, 4, 25, 36. Okay, so the guy wanted to take the average of these to figure out the standard deviation, but we had a problem because we have negatives. So we're going to square them first. So now all the negatives are gone. And then we're going to take the average of these. So we're getting there. It's a long story, as you can see. Now, check this out. The story's not over. The complicated part of the story is still not over. So what are we supposed to do? We're supposed to add these numbers, right? So let me go ahead and add them. So 25 plus 16 plus 4 plus 25 plus 36. I'm trying to find the average, so what am I supposed to divide by?
5.
But listen up. If you're not confused yet, you're going to get confused now. We're not going to divide by 5. We're going to divide by 4. Okay. A lot of stuff to tell you. First thing to tell you is you always divide by 1 less than how many numbers you have. That's why, let me go back a couple slides. When I wrote down the description, I wrote it's the square root of the almost average. The reason I wrote the word almost is because you have to divide by 1 less than how many numbers you have. Okay, I'll explain why you do that in a couple minutes, but you divide by 1 less. So if there was 9 numbers here, what would you divide by?
8.
8. So you add them up, you divide by 8. And then the last thing you do is you take the square root of this whole mess. Why are we taking the square root? Because remember how we squared the number to go from here to here? Now that the positives are gone and I take the average, now I'm kind of going backwards and square rooting it. Okay, so you square root that and then that's your standard deviation. We'll calculate it in a second and I'll show you how to calculate it. But let me just go through the story one more time. Find the average of all the numbers. Subtract each number in your data set from the average. That gives you these deviations. You square them all. Then you add them up, divide by 1 less than how many you have, and then you take the square root at the end. Okay, now let's pull out the calculator again. There's some more stuff I need to teach you about the calculator. How do you type this in the calculator? This is the way I want you always to do it. Well, you don't have to do it this way, but this is going to be very useful, so check it out. When you're taking the square root of something, my advice to you is do the square root at the end. This is what I'm going to do. Ignore the square root here for now. Pretend the root's not there. So what am I supposed to do? I'm supposed to add all the numbers and then divide by 4. So 25 plus 16 plus 4 plus 25 plus 36. You get the answer to that, right? You add them up, get the answer. Then you're going to divide by 4. Get the answer to that. And now I'm going to take the square root of that. Okay, so you do the inside of the root first, and then you take the square root at the end. Taking the square root at the end is going to be very important to us later on when the inside is really nasty. You know, it's going to be very important. So check this out now. How do you take the square root at the end? This is what you do. The square root symbol is right here in blue, right above the x squared button. Because it's in blue, you got to push second to access it. So you push second, square root, okay? And now you could just type in the 26.5, but don't do that. Check this out. There's going to be times in here we have to take the square root of a real nasty number, and you're not going to want to type in that real nasty number. So this is the way you do it. After you do second, square root, you're going to push second again, and you're going to go down to the negative sign. Right above the negative sign, it says answer. That's going to take the square root of the previous answer, which is 26.5. Memorize that. Second root, second answer. Whenever you want to take the square root of your last answer, it's going to be very useful to us. Second square root, second answer. Anyway, there's the answer. Okay, this is the standard deviation. 5.147, 81507. Okay, that's the standard deviation. That's the story. That's kind of like, that's what the person must have gone through to come up with his standard deviation that he finally came up with. And this gives me, what is this? This is a statistic, right? because it was calculated from a set of data. So this number is a number calculated from a set of data. So it's a statistic, and it gives me an idea of how spread out the data is. Okay, now that I've told you this long story, this is not how you're going to calculate the standard deviation. I'm telling you a story. Listen, when you take a class, especially a math class, learning how to do the problem is one thing, but understanding the story behind it is another thing. You need to know both of those things. So I'm trying to show you where it came from, okay? But now what I'm going to do is I'm going to show you a better way to find the standard deviation. So I don't ever actually want you to do it the way I just showed you, but I'm showing you where it came from, okay? So that's the idea. I don't advise you to do it this way because number one, it's long. Number two, if like the average is an ugly number, all these are going to be ugly. All these are going to be ugly. It's going to really take a long time. And on a quiz especially, you'll run out of time. You know, you'll still be working. You'll be halfway through standard deviation and the time will be up. So I definitely don't want you to do it this way, but I want you to get the story. Okay, so now how are we going to do it? Okay, so I'm going to give you, there's two other ways. This is like the long table way, okay? There's the formula way, which is the way I want you to do it every time on a quiz or an exam. And then there's a real fast way to do it on a calculator. Now, listen to what I'm saying. As far as doing it on the calculator goes, I do not want you to do it like that in class. So on quizzes and on exams, you're not going to do it that way. You're going to do it the way I'm about to show you. But I need you to know the fast way because in the homework, sometimes you're not going to be given like 5 numbers. You're going to be given like 100 numbers. Okay, and if you're given 100 numbers, then you kind of want to just get the answer the real fast way using your calculator. Okay, so I'm going to give you some formulas. Okay, cool. So first of all, these are formulas for the average. If it's population data, the symbol for average is mu. And the way you find the average is you add the data. Remember, X stands for your data. And this symbol here means add, okay? So you add all the numbers in your data and then you divide by how many you have. Remember that N stands for how many numbers you have in your data, but capital N is how many numbers you have if it's population data. So that's just what you already know. Add all the numbers, divide by how many you have, and that'll give you the average. But I'm using the correct symbols here. Capital N if it's population data, and mu if it's population average, okay? If it's sample data and you're trying to find the average, the symbol is X bar. And the way you do it is you still add the data and you divide by how many you have, but the number of things you have is lowercase n if it's sample data we're talking about. So there's formulas for how to find the average. I need those for what I'm going to show you in a second. Let's go to this page. This is the formula for standard deviation. Okay, so what we just did is this right here. The table method is this right here. Let's take a look at what this says here. To find the sample standard deviation, remember it's sample standard deviation we're finding because it's sample data. What do you do first? You find X bar, the average of the numbers. Then you subtract each number minus the average. You square them, okay? Then you add them all up. You divide by 1 less than how many you have, and then you take the square root. So this formula here is just summarizing the table method we just went through, okay? That's the table method there. Okay, but now if you take the formula for X bar, you see there's an X bar here. Let me go back to the previous slide. If you take this formula for X bar and plug it in to this formula right there, and you do some algebra, which I'm not going to show you right now. It's not hard, but I'm just not going to show you right now. You get this formula. This is the formula that I want you to use when you're finding standard deviations. It's much faster to calculate standard deviations using that formula. Okay, so we'll use this one instead. Because notice there's no X bar anymore, but there are 2 sums. But anyway, this is how we're going to find the standard deviation. Okay, now, a couple more things to tell you, and then we'll do an example of that. Notice there's an n-1 over here in this formula because you divide by 1 less than how much data you have, than the amount of data you have. But if you had population data, which you almost never do, but if you have population data and you're going to find the standard deviation, then you don't divide by n-1, you divide by n. You divide by the number you expected. You divide by how many numbers you have. Let's take a look at this formula. That table method again, what do you do first? You find the average of all the numbers. But if it's population data, mu is the symbol for the average of all the numbers. Then what do? You subtract each number minus the average. Then you square them all. You add them up and divide by how many you have, not 1 less, and then you take the square root. That's the formula for population standard deviation. So the way you calculate standard deviation depends on if it's population standard deviation or sample standard deviation. But as I've already said, almost always the data is going to be sample data. So you're going to be using these formulas, basically this one, to find the standard deviation. But if you get a problem in the homework where it says find the population standard deviation, like this is population data, find the population standard deviation, then you're going to have to do it this way. You're going to have to use the table way, okay? And then you're going to divide, don't divide by 4, you would divide by 5, by how many numbers you actually have. Only if it's population data. Okay, give me another second to try to explain why that is. Okay, so I want you to imagine this is population data. So a bunch of numbers in this bag, okay? And I want you to guess mu. I told you the first day, right? That's one of the kinds of things we're gonna wanna do. Figure out the average of all the numbers. Okay, so what would you do? You're not gonna take them all out of the bag and calculate the average because then you wouldn't need a stats class. What are you gonna do? You're gonna take a sample, you're gonna put your hand in the bag and you're gonna grab some of the numbers and you're gonna find the average of the numbers in your sample, which is called X bar. And X bar is your best guess for mu. So imagine we actually had a bag of numbers, and let's imagine we were in a classroom and I passed the bag of numbers around and I make each student take like 100 numbers out of the bag and you calculate the average of your 100 numbers, and that's your guess of the average of all the numbers in the bag, okay? And then I say, okay guys, now I wanna know what all your answers are. So I draw a number line on the board. I say, okay, come and tell me what your answers are, okay? Someone says, okay, my answer is this, like, 12.8. Someone says it's 13.4, another one, 13.9, 12.9, 12.4. And people come and put, a mark on the number line where their X bar answer is. Okay, and after all the students in this class do this, we'll get a picture that looks something like that. Everyone's gonna have a different answer because you got your own 100 numbers, okay? So you're not all gonna have the same answer, but you're all gonna have an answer that's a guess for the average of all the numbers in the bag. And then imagine I take the bag home and I take every number out of the bag and I actually calculate the average mu. What'll end up happening is mu will be right in the middle of all your answers. So all the little red lines are all your X bar answers, all your guesses for mu, and mu will be right in the middle, okay? So you guys are calculating sample averages. I went home and calculated the population average, and some of your sample averages will be smaller, some of them will be bigger. 50-50. Some of you will have an X bar less than the right answer. 50% of you will have an X bar answer less than the right answer, and 50% of you will have an X bar answer bigger than the right answer. That's called an unbiased estimator. X bar is an estimate of mu, and it's called unbiased because half of you are going to be less than the right answer, half of you are going to be bigger. Now, when it comes to standard deviation, okay, if we didn't divide by n minus 1, okay, like I told you, 1 less than how many you have, if you just divided by n for sample standard deviation, then this is what would have ended up happening. So again, imagine we have a bag of numbers. This is a bunch of numbers, population data. And I ask everybody in there to guess what the standard deviation of all the numbers in the bag is. So you take 100 numbers out and you calculate S. And I draw a number line on the board and I say, okay guys, once you have your S, come and put your answers on the board. So everyone will have answers, tick marks on the board somewhere. And if you don't divide by n minus 1, if you divide by n, then what will happen is, so I'll take the bag home and I'll calculate what the standard deviation of all the numbers in the bag is, and it'll turn out that the right answer for sigma will be like here. Most of you will have a guess for sigma that's less than the right answer, and just a couple of you will have a guess for sigma that's bigger than the right answer. So all the red lines are all your guesses for S, all your S answers, but sigma is the actual standard deviation of all the numbers in the bag. And this is called a biased estimator. Most of you will have an answer less than the right answer. And to make it unbiased, you divide by n minus 1. If you were to divide by n minus 1, it turns out that sigma then will be right in the middle. So half of you will have a smaller answer, half of you have a bigger answer. So that story was very complicated, okay? If you didn't understand what I'm saying, it's okay, but I just wanted to tell you why it is that we divide by n minus 1. The reason we divide by n minus 1 is to make S an unbiased estimator of sigma. Okay, that's the reason. If you didn't understand that, it's okay. Just make sure you remember that when you're calculating standard deviation, you got to divide by n minus 1. All right, let's move on. So, and then here are the formulas for variance. I just took the formulas for standard deviation and I squared them. So I'm squaring everything you see on this slide, and when you square them, this becomes sigma squared, this becomes s squared, and when you square roots, they go away. So this root, and this root goes away, and there's formulas for variance. But we're not really going to need them, because once you know how to find the standard deviation, you can just square it to find the variance. Okay, so let's go through this example real quick. Here's some data. It says find the range, standard deviation, and variance. Okay, so this is the way you're going to do it on the quiz now. Okay, let's call this part A, the range. You can put the data in order if you want. Maybe I should do that first, because on the quiz you're going to do that for the other stuff. So data in increasing order. Okay, so we did this already because it's the same data from before. 2, 4, 8, 11, 17, 23, 31. I feel like I missed something. 19 I missed. Okay. 19, 23. Okay, to find the range, you just subtract the highest minus lowest. Highest minus lowest. So you're going to do 31 minus 2. Okay, highest is 31, lowest is 2. And you get 29 for the range. Any questions on the range? Okay, so to find the standard deviation now, remember, if I don't tell you what kind of data it is, it's sample data, so it's S that we're looking for. Here's what you're going to do. This is the way you're going to do it. In order to find the standard deviation, you have to find two sums. The first sum is sum of x squared. Let me make sure you understand what this means. Remember, this means add. This is your data, and this is saying square each number in your data. So you have to square each number in the data and then add them. So you're going to do 2 squared. Parentheses are not important unless there's a negative number, but I'll just put it anyway. And then 4 squared. You're going to square each number and then add them. Do that on the calculator real quick. Okay, so it's real easy to do. You just do, 2 and then push the square button. 2 squared plus 4 squared plus whatever the numbers were. So 2 here. Okay, 2 squared plus 4 squared plus 8 squared plus 11 squared plus 17. Just square each number and then add them up. Plus, and you just do it like this, you can get it done all at once. Plus 23 squared plus 31 squared. And there's the answer to that, 2, 3, 4, 5. Okay, you guys follow me on that?
Yes.
All right. And then the other sum you have to find is sum of x, which is even easier. It just means add the numbers in your data. This means add, and this means that your data. X stands for your data. So add the numbers. So you're just going to do 2 plus 4, no squaring or anything. Just add all the numbers up. Okay, and when you're done, I think we did this already. I think it was 115, but I'll double check it real quick. Let's see, 54, 73, 80, 90, 109, 10, 15. Yeah, 115. So to find the standard deviation, you got to find those sums first. Okay, then what you're going to do is you're going to plug into the standard deviation formula. Now, I'm going to give you the standard deviation formula on the quiz next time. But let me go ahead and write it down over here. So standard deviation formula is sum of x squared minus fraction line, sum of x in the parentheses here, all squared over n, all over n minus 1, square root of all that. And then you just fill into this formula. Over here, it says sum of x squared. You're going to put there this sum of x squared answer. So 2, 3, 4, 5 goes there. Oops, what happened? Okay, and then minus, now you're going to put a fraction line. You're going to put a parentheses on top. You're going to put a square outside. Inside the parentheses, it says sum of x. You're going to put there your sum of x answer. The 115 goes there. Okay, and then the n is how many numbers you have. We have 8 numbers. Okay, if you count them, there's 8. So you'll put 8 over here. Down here, 8 minus 1. And then you have to square root all that. That square root looks really funny. Okay, and then you calculate that. All right, let me show you how to calculate this now. All right, so the way you're going to do that. So again, the idea is take the square root at the end. So first thing you're going to do is you're going to type in, let's see, 2, 3, 4, 5, 2, 3, 4, 5, minus, open parentheses, 115, close the parentheses, square, divide by 8. So just type, ignore the root for now, and just type everything above the big fraction line. Get the answer to that, so we have that. Then what you're going to do is you're going to divide by, so you're supposed to divide by 8 minus 1. I don't advise you to type 8 minus 1, because if you type it in wrong, it could mess everything up. So just push divide by 7. Okay, so divide by 7. Now that's the answer for what's inside the root. And now I have to take the square root at the end. And again, remember how you take the square root at the end. You're going to go second square root, second answer. Second root, second answer. And there's a standard deviation. And that's how you're going to find it. Okay, let me take a picture of this one. Okay, any questions? All right, so the answer for the standard deviation is 9.94179. 4894. 48, that's a 9 right there. 4894. Okay, let me go to the second page. So one more time, the standard deviation, this is part B. Standard deviation is 9.94179. 4894. Okay, so that's how you're going to find the standard deviation. Okay, next thing. Find the variance. It's real easy now. Okay, the standard deviation is the hard one. Once you have the standard deviation, the variance is real fast. All you do is you square the standard deviation that we just found. So the variance is s squared. You just square this number. Don't round the number, square the whole thing. All you have to do really is push the square button on your calculator now. Okay, if the number is still in there, just push the square button. And the answer to that is 98.83928571. So that's the variance, and that's the standard deviation. And that's example 4. Questions on example 4?
Professor?
Yes.
Isn't the variance just the number while we're calculating the standard deviation before we take the square root?
Exactly. That's right. Yeah.
Okay, cool. Thank you.
Mm-hmm. Okay, other questions? Okay, let's go to the next example. So okay, here it says, this is just me trying to remind you that, you could be in different situations, but if you know one of these, the other one is very fast. So if you know the standard deviation, this arrow means if you know the standard deviation, how do you find the variance? The answer is, what do?
Square it.
You square it. Yeah, that's what it says. And if you go the other way around, let's say for some reason in a problem you know the variance and you want to know the standard deviation, how do you find it?
Square root it.
You square root it. Right, so square root it. A couple of quick examples to practice that. If the standard deviation of a data set is 9, what's the variance? What's the answer?
81.
Yeah, you square the 9. Okay, so like if this is 9, this is 81. Okay, that's what's happening there. Okay, and then let's go the other way around. Example 6. If the variance of the data set is 9, what's the standard deviation? So if you know that this is 9, what's this one?
3.
3. Yeah, you just square root it. If you know the variance and you want to find the standard deviation, you square root it, and the answer is 3. Those are just real quick examples that I usually don't even write anything down for. Any questions on 5 or 6?
No.
Is
Okay.
is the standard deviation always supposed to be positive?
Yes, standard deviation and variance are always positive. All right, so then we have these last 2 examples. These are really important as far as communication goes. But go over them a lot because I always put this on the quiz. I always put something like this on the exam kind of thing. So let's see what it says here. Suppose you have 2 data sets. Let S1 be the standard deviation of data set 1. Let S2 be the standard deviation of data set 2. If S1 is 8.3 and S2 is 4.1, what can you say about the data sets? Okay, when I say data set, you should be imagining a bunch of numbers on a piece of paper. So data set 1, okay, it's a bunch of numbers on a piece of paper. The standard deviation of those numbers, we're calling it S1. S is what we use for standard deviation, but there's 2 standard deviations in this problem. So I'm calling this one S1 because it's calculated from data set 1. Then we have another data set 2, which is another set of numbers. And the standard deviation of those numbers is S2. Now in this example, I'm telling you what these are, and I'm asking you about this. So listen carefully to what I'm about to say here. This is a single number and this is a single number. So when you're talking about these 2 numbers, you need to say that one of them is bigger than the other, or one of them is smaller than the other, okay? Because we have 2 numbers. But when you're talking about a data set, when you're talking about them, it doesn't make sense to say data set 1 is bigger than data set 2. That doesn't make any sense. How can a piece of paper with a bunch of numbers be bigger than another piece of paper with a bunch of numbers? Doesn't make sense. When you're talking about data sets, one of them is more spread out than the other, or one of them is less spread out than the other. So I want to make sure you're clear on that. Don't ever say one of these is bigger than the other. And when you're talking about S1 and S2, don't say that S1 is more spread out than S2. These things don't make sense. So when it's individual numbers, one of them is bigger than the other. When it's a group of numbers, one of them is more spread out than the other. Okay, so keep that in mind as we answer this question. So in this question, it says, this is 8.3, this is 4.1. What can you say about the data sets? What can you say about the data sets? Can anyone answer the question?
Data set 1 has more spread out data points or more variance than.
Okay, just say data set 1 is more spread out. Keep going. Data set 1 is more spread out than what?
Data set 1 or data set 2. Sorry.
Than data set 2. Okay, and then why? Okay, so I want you to compare these numbers. So these are the numbers that are letting you know what that information, right? It's because S1 is what?
Bigger than S2.
Bigger than S2, yeah. Okay, listen. When you do this problem, I want you to first answer the question, what can you say about the data sets? There's the answer. And then I want you to say why, because the S1 number is bigger than S2. Again, when you're talking about these, make sure you say one is bigger than the other. When you're talking about these, make sure you say one is more spread out than the other. Okay. And the other thing, sometimes I see students write, they'll write data set S1. This makes no sense at all. There's data set 1, there's data set 2, then there's S1, and then there's S2. There's no data set S1. So the point is, I really like this problem because it really practices communication. So first thing it practices is, do you know what standard deviation is supposed to tell you? Standard deviation is supposed to give you an idea how spread out the data is. So because this standard deviation is a big number, that data set is really spread out, and this is a smaller number, this data set is not as spread out, okay? But that's how you write it, okay? So first you answer the question, data set 1 is more spread out than data set 2. How do you know that? Because the S1 number is bigger than the S2 number. Okay, we got one more like that. This is basically the same example backwards, okay? So we have two data sets. There's data set 1, bunch of numbers. There's data set 2, bunch of numbers. It says S1 is the standard deviation of data set 1, S2 is the standard deviation of data set 2. Without calculating them, which one is bigger, S1 or S2, and then why? Okay, let me draw a picture again real quick. So again, we have data set 1 is a bunch of numbers on a piece of paper. Data set 2 is another bunch of numbers on a piece of paper. And then S1 is a single number. Okay, it's the standard deviation of that data set. It gives me an idea of how spread out that data set is. S2 is a single number. It's the standard deviation of those numbers. It gives me an idea of how spread out these are. Again, when you're talking about the data sets, one of them is what?
One more spread out than the other.
More spread out than the other. That's right. And we're talking about the S's. One of them is
Bigger than the other.
bigger than the other. That's right. Okay. So in this problem, though, I'm not giving you the S's. I'm giving you the data sets. And so I'm asking you which one is bigger, S1 or S2, and then why. Let's first answer the question, and then we'll say why after. So which one is bigger, S1 or S2?
S2.
Is bigger than S1. Again, it doesn't make sense to say S2 is more spread out than S1 or anything like that. You're right, S2 is bigger. And now you got to tell me why. Because why?
Because data set 2 is more spread out than data set 1.
Exactly. Because data set 2 is more spread out than data set 1. Make sure you guys also saw that, you know. These numbers are all big numbers, yeah, but they're all very close together. They're all 750 something. Whereas these numbers are very spread out. They go from 1 all the way to 63. Okay, so that's it. So again, answer the question first. Which one is bigger, S1 or S2? S2 is bigger than S1. Okay, and again, we talk about those two. One of them is bigger than the other. Then why? Because this data set 2, which is this, is more spread out than this data set 1, which is this. Okay, that's how that one goes. Guys, please practice example 7 and example 8 for the quiz. I'm super picky on your answer. It's for the most part all or nothing when I ask you that question on the quiz. You know, it's either 0 or I think it's we're out of 2 points. So it's either 0 or 2 points. And on the exam, it might be more. So study that really hard. Okay, guys, for this last couple of minutes, I'm going to go over how to calculate the standard deviation of a set of numbers really fast. There's a really fast way of doing it. Basically, you just type it into the calculator and the calculator does it for you. But before I do this, let me just make sure you understand that on quizzes and exams, I don't want you to do it this way. I want to show you how to do it this way so that if you need the answer really fast, you can get it, and also you can check your answer. But on quizzes and exams, the way that I just showed you how to find standard deviations and variances and things like that, that's the way I want you to do it, where you show all the work. And of course, when I'm grading, you know, if you don't show any work, you just write the answer. I don't give credit anyway, so make sure you show the work. But again, if you need the answer really fast, if you're doing an online homework problem and the data is a huge set of data, then I'm not going to want you to do it the way we just learned because it'll take forever. Then you just put in the calculator and get it really fast. So anyway, let's go ahead and do this example. It says use a graphing calculator to find the standard deviation of these numbers. So let me pull up the graphing calculator here. And so this is what you're going to do. So let me move it over here. So first thing you're going to do is you have to, basically you're going to enter the data. And then after you enter the data, you're going to tell the calculator, tell me the standard deviation. So to enter the data, what you do is you go to this button. There's a button right here. It says stat. Okay. So you push stat and there's a bunch of choices on top. Edit is the one you want. So edit, and then it says edit. So you just push enter and it gives you a bunch of lists, list 1, list 2, list 3, list 4. And you enter your data in list 1. Actually, you can enter it in any list, but if you don't need the numbers in list 1, it's a little bit easier if you enter it into list 1. So I'm going to enter these numbers here. If there's already numbers there and need to get rid of them, well, you can type over them. So that's one thing. But, you know, what if there's like, 20 numbers here and you're only entering 15? What about the other ones? You need to delete the other ones. So if you're trying to delete numbers, if they're already there, you click delete. Okay, so if you're trying to delete individual numbers, you can click delete like that. If you want to erase everything in the list, this is important. Make sure you pay attention to this. If you want to erase all the numbers on the list, what you do is you go up to where it says L1, but be careful what you press. Do not press delete. It'll delete the whole list. The L1 will just be gone. We don't want L1 to be gone. We just want the numbers in L1 to be gone. So what you do is you go up to L1 and you push clear. and then push enter. I think one time is good enough, and then it'll get rid of it. So let me go over that again. So there's numbers there. If you want to delete individual numbers, you just click, just highlight the number and click delete if you want to delete one specific number. But if you want to delete all the numbers, do not push delete, push clear, enter, and it'll get rid of all the numbers. And again, another thing you can do is you don't have to delete the numbers. You can just write over them. So here, let me go and do that now. So I'm going to enter these numbers in list 1, 6, 11, 14, 35, 58, 91, 115, 127. So that's the first thing you do. You enter the numbers, enter them in list 1. If you have numbers in list 1 and you don't want to get rid of them, you could enter it in another list. But let's first talk about how you do it if you enter it into list 1. So you enter the data there. After you enter the data, then you go back to stat. So push stat again, and you're going to go over 1 to where it says calculate. And then you want the first option that says 1 variable statistics. And once you push enter, it'll calculate a bunch of things for you. So you push enter. Now it depends on your calculator. Some calculators will display it a little bit different. But see here, it says list, it says L1. It's saying the data is in list 1. If for some reason you enter the data in a different list, then you have to change this L1 to whatever list you entered it in. Let's say you entered the data into list 2. Then see here, above the numbers 1, 2, 3, it says L1, L2, L3. So if you listed the data in L2 instead, you just need to type L2. Because it's in blue, you're going to push second first. You go second, L2, if your data is in L2. But if your data is in L1, then just let it say L1. And if you don't tell it what list it's in, the calculator is going to automatically assume that it's in list 1. That's why I tell you, if you don't need the numbers in list 1, then type the numbers in list 1. Okay, then we push enter a couple times, and there you go, and you get these answers. So it calculates a lot of stuff for you, but the standard deviation is what we want. So that's it. You type the data in the calculator, push a couple buttons, and the calculator will calculate all these things for you. If we're looking for the standard deviation of these numbers, this is the one that says S. So this one here, this is the standard deviation of those numbers. So the standard deviation is 48, 507, 54728. And that's it. Now, we know there's two different types of standard deviations. One if it's population data, one if it's sample data. Remember, if I don't tell you what kind of data it is, it's sample data. So if we're assuming this is sample data, nowhere in the problem do I say that it's not. So that's sample data. So then this is the standard deviation of the numbers, the sample standard deviation. If for some reason the problem says that this is population data, this will almost never happen. But if you get a problem and it says, just for this problem, pretend that the data is population data, then define the standard deviation, that's the next one, the one that says sigma over here. So see, it gives you both. It gives you the sample standard deviation if your data is sample data. It gives you the population standard deviation if your data is population data. So the standard deviation then would be sigma, which is 45.37465565. Okay, so that's how you have the calculator calculate the standard deviations for you. And it calculates other things for you as well, like it calculates the average in case you need it, calculates a few other things there. But once again, only use this to double check your work after you've done the work the way I already showed you how to do it on a quiz or an exam. Or in your online homework, if it's a lot of data, then go ahead and use this feature so that you can get the answer right away. But the point is, I don't want you doing this for quizzes and exams because what's happening here? What's happening is the calculator knows how to find the standard deviation. And you're just pushing the right buttons to get it to do it. But I want to make sure you can do it. Okay, so when I'm grading quizzes and exams, you do it the longer way. But this is something useful to know, especially if we need a standard deviation right away. Okay, guys, that's it for today. Study hard. See you next time.